welcome back to part 2. So this part we will discussing about the preparation for virtualization, so that before you deploy or you implement the virtualization part, customer or you as a user, you need to prepare for consideration or in advance. You need to know the nature of your application, which type of application require specific high performance or specific workload requirement. So then you can decide which application need to be hosted in same physical machine, which actually did not require, or some application require to be hosted in similar data center, or can be part of it can be hosted on cloud, part of it in your own premise. So you need to know your own business, your own application requirement before you can deploy well in this particular infrastructure. Okay, so generally there are 5 steps to be followed. This is as guideline, right? For example, the server selection, server sizing, server criticality, provisioning, proximity, and locality. First step here, you need to see the server selection criteria. Before you move to virtualization, is to shortlist the servers that are best candidate for virtualization. Because some server which host specific application, they require to run in physical mode, which they need to communicate directly to hardware. So it's not suitable for virtualization. So let them stay in the physical environment. So as prerequisite, the customer must have a detailed inventory list of all the server in your data center. So each server will be marked with its individual capacity, architecture type, OS version, application version, and monitoring tools that you use to monitor this particular server. For example, if the server itself already fully utilized, that means utilization 60% and above, that means no need to virtualize it, right? They require very high number of resources by themselves, cannot be shared. Okay, the worksheet must also provide a detailed view of the network and storage designated for application usage. You see here, network and storage either external and internal, because some of the application they require external storage for their database, for their object storage. For some application they only needs their own direct storage. For example, your network configuration, your monitoring servers, right? It did not require very high storage capacity. So direct attached storage still can be used. And then customer must run performance tools to determine the effective utilization of each server. One more time, I said about the utilization, correct? So if that particular server already reached more than 60% utilization, that means enough, no need to virtualize it. They require high resources. If you share, then the performance will be downgrade. And then a server may be marked as good candidate for server virtualization based on these factors. So this is the guideline only. If the server is effectively running at utilization not greater than 20 to 40%, then you can consider this server to be virtualized, and they can share another resource which not utilized. If utilization higher, then no need. It's not good candidate for virtualization. And then the server is not running an application that place high demands on the hardware and make assumption on the OS and hardware, especially in the case of proprietary application, operating system, and hardware. Because there are some applications that are highly relies on the specific hardware, which they communicate directly to the kernel and the hardware, cannot be adding more layers like with hypervisor layers. They will introduce a new latency or new performance penalty. So then it's not stable. If not, if they didn't require that kind of thing, then you can do. Okay. And then the server hardware support the advanced virtualization capabilities for hardware assisted virtualization. So mean if your server support Intel VT and AMD V, then that's good candidates of hypervisor, because most of the hypervisor or virtual machine manager require this extension or the features of the CPU. Okay. And the servers geographically located at the same place can be made VM or single server.
I can hear you clearly.
As long as the individual physical server has enough space capacity. For example, for performance reason, we want to place the application server close to database server, because if you implement or deploy 3 tiers web application, you have web server, application server, and also database server. These 3 components should be in the similar data center so that they will not introduce new performance overhead. Then the delay also can be reduced compared to you put one application, your web server in different data center, and then your database server in a different data center. The communication between these component also will affect your user experience. Okay, the delay will be there, jitter and so on. And then provision to the designated extra server as standby hypervisor server to take over VM in case the primary hypervisor server fail. So if let's say you can have can put like 1-to-1 or n-to-1. That means if you have multiple application server or physical server, you should have extra, that means one or more servers that can become your standby server. Passive, active, passive. Active passive can be, but active passive also can be. That means the extra server become the standby or backup part lah, right? If let's say you have 10 servers running, one of the 10 servers down, then this extra server can take over the function of the down server. Okay, so design into extra. The firewall server may be retained as physical server, though it's not necessary. Depend lah. Sometimes firewall is in the server or appliance base or router base, depending on your implementation. Some of it are in the server. Okay. Host, for example, host based firewall, application or web application firewall, normally they are in specific server. And then identify restriction on co-locating different server on the same machine or for security, compliant or non-technical reason. For example, like I said before, your web application and application server, web server and application server in similar physical machine, or your application server and your database server in same physical machine, although you can make it as a different segment, isolate them, but still in the same physical machine. Because in the same physical machine, the communication between the application server and database server will be faster because they didn't require to go outside the machine. They are communicate internally. You also can set this as a host only communication and create the virtual LAN for the virtual segment. So this is for security and non-technical reason. Also performance. One physical server are shortlisted should be virtualized, then you can proceed to the next step in consolidation. Okay, what next? Once you identify, then all qualified server for virtualization will be classified under 2 major categories. Either the hypervisor and VM, which server will hosted specific hypervisor. A section of physical server will be configured as hypervisor, And the sizing for the advisor would be based on the following point: add up resource requirement for all the qualifying physical server. That means you can add up the extra RAM, extra storage, so that you can serve more user. Add 30% headroom to calculate total capacity to handle peak load. That means extra 10% capacity calculated total capacity to account for hypervisor and management overhead. That means you need to put at least 10% extra before you accommodate or before you allocate for others, because 10% consider the management monitoring your hypervisor requirement, right? For example, you have 64 gig RAM, at least 6 gig RAM actually already consumed by your hypervisor and your management console or agent, right? Done. So only 90% of your resources can be allocated. However, another 30% you can put an extra to handle peak load. That means in total maybe you only can utilize 50% of it for the normal usage, plus another 10% for hypervisor and another 30% for peak load or extra required or extra requirement. For example, once the application are in a high number of user, then this will be utilized. Then get list of physical high-end server that match the total capacity required. This server will be configured as hypervisor and used to host other VM. The OS and application hosted on this physical server prior to virtualization will be deployed as VM on this server. And then remaining physical server can be released or freed up for other use. Then when you calculate everything, you can see there are some saving in terms of resources. You can make that particular free service or free resources to become redundant component, backup system, and additional usage. In case of disaster recovery infrastructure, the physical server can be consolidated on the other side using the same procedure. Which means you have your primary site, then you configure, you identify, calculate everything. But in your DR side, in different data center, you can use the same configuration, okay, the same procedure. So you can have replica for your primary data center. In case of high availability infrastructure, virtual machine corresponding to this passive node will be created and placed on different hypervisor than one hosting the primary node virtual machine. I said before, you have a free server which not utilized, then you can make it as the passive node or standby node. If anything happen to the primary node, then it can be take over depending on your setting. Is it you want the asynchronous data asynchronous replication, or you want only passive node? Depend on the high availability requirement for that particular application. So restriction on the movement of VM on hypervisor nodes will affect sizing and additional physical nodes. So the capacity need to be accounted for this case. So there are some restriction. So you need to consider, if let's say some application cannot be moved to another VM, then make it stay in the what they have been implemented. Another criteria, right? Another step here. Second step, we need to identify the server criticality. A set of server that serve critical function in the organization can be retained as physical server. Like I said before, if they must require that particular resources to be hosted, then let them there. No need to virtualize it, so that the server can be marked as critical if it's qualify for one of the following criteria. This is the criteria when you want to identify or classify specific server as a critical server. Example, one of it is serve a critical function of the organization with heavy reliance on hardware and OS level features. For example, database server makes extensive use of
So far,
OS
no question at this
and
moment.
hardware
Let's
facilities.
proceed with the student presentation, and then the feedback will
In
come
some cases
after it.
directly.
Thank you.
Okay. Virtualizing this server lead to major downgrade in performance due to the extra emulation layer required to slower virtual I/O mechanism in VM. If that application requires direct communication between application to the kernel to the hardware, then don't virtualize it, because when we virtualize, it introduce new layer, new surface, then they can open new surface for the attack or surface for performance downgrade, and that is still in physical machine. Then about the legacy application and system, if this legacy are not easy to port to stand or to open standard, that means this require very customizable. That means the system or the server itself only have specific hardware can run that specific system or legacy system. Then the virtualization solution cannot support this kind of thing, then let them stay in the physical machine, because some of the legacy system have huge dependency on the underlying OS and hardware for operation, cannot be virtualized, then let them stay. Other than that, server that constantly run at higher utilization, about 90% or 95% of the time, that means in average you can see in 24 hours maybe only 1 hour or 2 hours the server running lower than 60% or lower than 70%, then no need to virtualize it, because constantly running in high capacity. Also, for security system that require high isolation to comply with existing compliant law, cannot be virtualized. For example, your IPS, IDS required to be in physical mode, because they require real-time monitoring. Then let them run in physical. Another step here, third step, about provisioning. So identify it. The central idea behind virtualization is to bring down the average provisioning time of server, because if you want to provision new server, you need to have a new procurement, right? Then new installation take time. Procurement also take a long time, until a month maybe, and then you need to install by yourself. So that they want to reduce it, right? Fiber core has been rapid growth in demand and reliant on IT in the last few years. This demand will continue to grow in future with the growth of the organization, so that new demand will require new server. This is normal, especially in new digital transformation nowadays. Most of the company moving to application system. So the current provisioning time for physical server in fiber coil about 6 to 8 weeks. This is the traditional one. The current implementation they require until 2 months, because they need to go through the procurement process, which require request for quotation, presentation from the vendor, and then assessment from the company. They need to prepare before that. They need to prepare all the spec. Took time, and then to issue the tender and a lot more. So until 2 months. So virtualization can bring down the provisioning time about 1 day, because there is, if you have existing resources lah. The following level would be see drastic improvement in turnaround time once virtualization is deployed. So a snapshot of VM can be captured and placed in central data store. The snapshot will have to entire configuration saved right from the hardware, OS, and customer specific application. So if you still remember, we take a snapshot for our server last time, correct? Then we just take that particular snapshot with the clone, the full backup of clone copy, then you can restore it into the new virtual machine very fast without require to install from scratch. Correct? In future, if there is need to bring up a server with the same configuration, it would be easy as to copy the virtual snapshot and power it on. As long as you got the snapshot in your central data store. If you still remember, I show you our server data store. So same concept. I put 4 or 5 image there, then I just use it if I want to deploy new operating system. Any number of copies can be created from the saved snapshot, thus result in drastic time saving for provisioning new server. And then the remote desktop also used by Fabercoil can be consolidated into a central server using desktop virtualization. So this is how we apply desktop virtualization. Addition of new desktop would be as simple as adding a VM to the central desktop server and sending details to the end user, especially for application that can only run in one license. So no need to install to all the user. Just put it in desktop virtualization mode and access it as a remote desktop. Hypervisor-based monitoring tools can be used to track a running status of VM, and the application monitoring can be used to track running status of application on VM as well. Actually, nowadays there are application or the monitoring tools that can done both. Can monitor the hypervisor, the VM, the application on top of the VM, and many more. The network, the security, they can be monitored. If you remember, I show you the vSphere, right? Our vSphere can monitor the specific physical server, but that's not centralized on this specific server which we run it, but we have centralized management console as well. Okay, the monitoring tools provide up-to-date run status, thus eliminate the delay in detecting server crash and downtime. This reduces overall downtime in the organization. I think that's all for part 2. So later we continue with part 3. Thank you. Okay, next we continue for another last step for preparing before we have the virtualization deployment. We try to see about the proximity and locality of your server. So virtualization enables dependent server to be placed together on the same physical server and co-located locally to enable better communication and reduction in communication and I/O latency. So for example, in traditional IT deployment, we have different physical server for web server, different physical server for database server and application server. But in virtual machine, is enable you to locate it or to place together your web server, application server, and database server, which actually highly dependent to each other in one physical server or in one local data center, so that you can reduce the communication latency, performance latency, and so on. So Fabercoil could make use this locality in the following ways how to do it. So the application servers and the database servers VM can be co-located together. So for example here, two tier of application server and database server. So can put together in one physical server, different VM, right? The server VM will have a VLAN between them on the same hypervisor. Hence, the traffic between this server will pass through the VLAN without being routed on physical network interface. So this way, the network latency can be reduced. So only external user to that particular server will be using the physical network interface. But communication between application and database server all inside the physical machine, singular physical machine. They can use host only, they can use bridge and so on, but still communicate inside. No need to go through or pass through the physical network. When you have to complete the communication or complete the transaction, then go back to the user, they will go to this physical network. And then, other than that, firewall, proxy, and the VPN server also can be co-located on the same hypervisor, thus allowing the reduced network latency between the server. You can use VLAN, virtual LAN, in similar physical server. Although in different physical server can also got VLAN, but here virtual LAN comes specifically inside the virtual machine or inside the physical machine. Okay, within the physical machine. Okay. And then we can see transition tools for virtualization from the physical or traditional IT infra into virtual environment. So virtualization vendor provide its own custom tools for consolidate a physical infrastructure. However, this tool can be broadly classified under this major category. This type of tools actually useful for organization for their capex or opex calculation, their estimation of the cost, the manpower and other space, right? So they got one tool's name is the Virtualization Assessment and Planning Toolkit. This toolkit in effect take the current IT landscape as the input and current constraints and provide a plan for virtualization and consolidation. That means as a user, you key in the current infrastructure that you have and then the current constraint for specific infrastructure, specific application, then they will suggest a plan for you for virtualization. And also you have TCO calculator. TCO means total cost of ownership. How much you need to pay to own this particular infrastructure, and also the virtualization infrastructure, total cost of ownership, TCO. Okay. So this worksheet provide mechanism for calculating the total saving and the total cost of ownership after moving to the virtualization. So you can compare, is it significant saving or not? Right? This is like one sheet, one Excel file. Then you put the numbers, input the numbers based on your current infrastructure, and they will calculate for you how many years you can get significant saving. Depend on your own input. And then another tool, they call it P2V, physical to virtual tools, are used to move from physical state to virtual state. This tool enable an admin to create a virtual copy of the physical server for deployment. Then when you got the physical virtual copy, that means the clone for that particular physical server, then can easily deploy in virtual environment. Then another tools as a management tool or manageability tools. This tool provide mechanism for creating, managing, storing and deleting virtual machine in data center. In addition to the basic functionality, the tools provide mechanism for monitoring, ongoing optimization of your current infrastructure. You can see previously VMware, they got multiple tools. One of the tools actually for their manageability or management tools, so that you can support all virtualization of virtual machine and also hypervisor that you provision. Okay. This is two. And then we talk about the cost saving. Typical cost saving explained by Fibercall after moving to virtualization is in range of 40%. This is the real case study. This includes saving on the data center space, physical servers, numbers, operational costs, and easy manageability of the infrastructure. When easy manageability means you can reduce the numbers of staff, system admin, or they can do other jobs which can double up the productivity. Okay, this is for virtualization. Cool. For next part, we'll continue with the cloud overview, cloud workload. Okay, we can discuss. Thank you.